The morning of March 3, 1944, found Lieutenant William Overstreet hunched over a pencil in his quarters, his hand wavering slightly across the paper as he composed a letter to the woman waiting for him back in Virginia. The exhaustion that gripped his fingers came not from fear, but from the relentless pace of preparation that had consumed his days and nights. He wrote about tomorrow's mission, the one that everyone had insisted was impossible. A single-seat fighter making the journey all the way to Berlin and back. Command had repeatedly told the pilots it couldn't be done. But through his window, visible under the harsh glare of floodlights, he could see ground crews moving with purpose around his P-51 Mustang, attaching peculiar cylindrical objects to the underwing pylons. These fuel tanks looked fragile, their surfaces wrapped in brown paper like parcels arriving from home. Some of the pilots joked about them, calling them paper bags. Overstreet questioned their durability, but the crew chief simply smiled. Made from laminated paper and plastic resin, the same materials the British have relied on for some time now, the chief explained. They'll carry enough fuel to complete the mission and bring you home safely. Through the lens of mechanical innovation, aerial warfare was about to transform. Not through heavier weapons or superior steel, but through compressed paper saturated with resin, created in a converted printing facility where workers normally produced the pages of the London Times. The urgency driving this innovation traced back to October 1943, when the bombing campaign nearly collapsed under the weight of its own losses. Colonel Hubert Zemke stood before the operations board at Halesworth, his eyes tracking the incoming reports of devastation. 60 of the Boeing B-17s had been lost, 600 men had vanished in 24 hours. The Strategic Bombing Force had dispatched 291 flying fortresses to strike at the ball-bearing factories of Schweinfurt. The Luftwaffe and flak batteries had torn 60 of them from the sky. Another 17 had suffered damage so severe that repair was economically unfeasible. The losses exceeded 26% of the entire attacking force. Without fighter protection throughout the entire journey, daylight bombing operations were hemorrhaging crews faster than they could be replaced. Among those who limped back to Thorpe Abbott that terrible day was Technical Sergeant Robert Morgan, whose position in the ball turret of a B-17 gave him a perspective on the massacre from below. Intelligence officers gathered around him as he recounted the experience. The German fighters held back their attacks, Morgan explained, until the escorting P-47 Thunderbolts reached the limit of their range and turned homeward. Then the enemy came at them in relentless waves, head-on assaults from single-engine fighters, devastating rocket attacks launched from twin-engine aircraft positioned safely beyond the American bomber gunners' effective range. For 3 consecutive hours, they were defenseless, exposed to methodical and concentrated assault. The P-47 Thunderbolt, impressive as it was, carried enough fuel to reach only 375 miles from base with its standard drop tanks. The German fighters simply waited beyond that invisible barrier. They had learned to exploit this limitation with brutal efficiency, plunging into the bomber formations with calculated savagery. In a modest office at the headquarters of the 8th Air Force Technical Section, located at Bovingdon, Colonel Cass Howe held an object that resembled a school project more than military equipment. The creation before him consisted of layers of craft paper saturated with plastic resin, manufactured by Bowater Lloyd of London, a company that had built its reputation producing the newsprint supply for Fleet Street publications. Howe had spent months pursuing this unlikely solution to the range crisis, collaborating with British engineers who had already begun investigating non-metallic drop tanks. Alongside Colonel Bob Schaefer, these men had recognized that unconventional materials might solve what conventional engineering could not. The British had been motivated by scarcity. Their aluminum supply was severely limited, every ounce precious and desperately needed for aircraft construction. But Howe perceived an additional advantage that transcended material conservation. These paper tanks weighed approximately 50 pounds when empty, compared to the 150 pounds required for metal alternatives. That weight differential allowed more fuel to be carried within the same aircraft capacity, extending combat radius substantially. The manufacturing process began with multiple sheets of craft paper bonded together using formaldehyde resin and oil-based glue. Technicians molded these laminated layers around wooden forms, incorporating internal wooden baffles to prevent fuel from sloshing during flight maneuvers. Once the basic structure was complete, workers applied successive coatings of fuel-resistant lacquer, followed by aluminum paint, giving the finished tanks their distinctive silvery appearance. The first operational test occurred in February 1944, when P-47s belonging to the 56th Fighter Group flew their first combat sorties equipped with the British-manufactured 108-gallon paper tanks. Major James Goodson commanded the formation and later documented in his official report that the tanks performed without flaw throughout the entire sortie, delivering pilots safely home with zero incidents of leakage or structural failure. Combat radius increased by 125 miles. Yet this achievement represented only the opening chapter of a transformation about to accelerate dramatically. Late February 1944 brought the P-51B Mustang to Debden Airfield. Colonel Donald Blakesley's 4th Fighter Group, composed of the 334th, 335th, and 336th Squadrons, received their initial shipment of Mustangs on February 28. The pilots faced an enormous challenge. They had less than a single day to transition from their familiar Thunderbolts to an entirely different machine. Captain Don Gentile, destined to become one of the war's most accomplished aces, logged exactly 45 minutes of flight time in the Mustang before his first combat encounter. Yet the combination of the Mustang airframe with these paper drop tanks would redefine everything. The Mustang possessed the capability to carry 2 of the 108-gallon paper tanks, now being manufactured in increasing quantities at Bowater Lloyd facilities located at Sittingbourne and Kemsley. With this fuel capacity, the P-51 achieved a combat radius of 850 miles. Berlin lay 580 miles from East Anglia. Suddenly, the impossible became possible. The briefing room at Debden on the morning of March 4, 1944, crackled with barely contained anticipation. Major John McAlpin, the intelligence officer, drew back the curtain concealing the mission map. A crimson ribbon traced the route from their base directly to Berlin. History was about to be made. For the first time ever, single-engine fighters would fly all the way to the enemy capital and back, escorting the heavy bombers throughout the entire journey. The round trip would stretch beyond 1,000 miles. It marked an unprecedented accomplishment that would fundamentally reshape strategic bombing operations. Captain William O'Brien of the 357th Fighter Group recalled that extraordinary moment decades afterward when recounting his experiences to Air Force historians. The silence had been complete and absolute. Then someone whistled a single disbelieving note. Berlin. We were actually going to fly all the way to Berlin in fighters. The crew chiefs had commenced filling those paper tanks at 3 in the morning. The task demanded meticulous attention. These tanks could safely contain fuel for approximately 5 hours before the gasoline began chemically degrading the resin binder. But 5 hours would prove sufficient. The engineering incorporated into these paper tanks possessed more sophistication than their humble appearance suggested. 3 primary components comprised each unit: the nose cone, the tail section, and the cylindrical main body. The central portion consisted of paper sheets impregnated with resin, wound around a cylindrical mold, while the end sections were assembled through hand layering of petal-shaped pieces known as gauze. Each tank accommodated 108 gallons of 100-octane aviation fuel, sometimes referenced as 110 gallons total, with 108 usable capacity. The containers measured 100 inches in length and underwent pressure tests to 6 pounds per square inch. They exhibited remarkable tolerance across temperature extremes and altitude variations, functioning reliably from sea level through 40,000 feet, withstanding temperatures from 60 degrees below zero to 120 degrees above. The workforce at Bowater Lloyd included numerous women who had previously worked in the newspaper trade, alongside production occurring at other facilities where distributed manufacturing spread across Britain, including home workshops and small factories. As 1944 progressed, production volumes climbed steadily to meet accelerating demand. Despite mounting combat evidence of effectiveness, American technical establishments continued expressing skepticism. Right field experts declared with absolute certainty that paper tanks were completely impractical and would prove incapable of fulfilling their intended purpose. Yet by the time this assessment reached England, The 8th Air Force had already deployed more than 15,000 paper tanks without recording a single failure attributable to defective tank construction. Colonel Howe's response remained steadfast and unwavering. He maintained momentum on production expansion, confident that actual operational results carried greater weight than theoretical laboratory assessments. The skeptics at Wright Field became increasingly irrelevant as the combat record accumulated. The Berlin escort mission launching on March 4th assembled over 700 heavy bombers, escorted by squadrons of P-51 Mustangs and P-47 Thunderbolts. Colonel Blakesley led the Mustang formations. His pre-mission briefing to the pilots, recorded by Captain John Slater of Intelligence, conveyed absolute confidence. "These paper tanks will transport you to Berlin and return you safely home," he instructed. "When you reach the initial point, release them and engage any enemy aircraft you encounter. With these tanks, we control the skies all the way to the enemy capital." The mission extracted costs. The 4th Fighter Group suffered the loss of Lieutenant Alan Bunting, shot down by flak near Brandenburg, yet the psychological consequences proved far more consequential than tactical losses. Oberleutnant Heinz Knoke of Jagdgeschwader 11 recorded his shock that evening in his personal diary. American fighters had appeared over Berlin. His intelligence briefings had insisted this was impossible. Everything his superiors had promised him was proven wrong. For the bomber crews, witnessing Mustangs patrolling above Berlin at 30,000 feet produced a transformative moment. Sergeant Dale Rice, ball turret gunner with the 100th Bomb Group, testified in official debriefings about reaching the bombing run when he spotted P-51s circling overhead with contrails streaming behind them. One fighter waggled its wings as it passed directly above the formation, and Rice could clearly see the drop tanks mounted beneath the wings. The impact struck immediately and profoundly. When bombers returned to Berlin on March 6th, escorted by Mustangs, Luftwaffe interception attempts diminished markedly. Major Walter Nowotny, among Germany's leading aces with 258 credited victories, reported urgently to Luftwaffe High Command. The Americans had resolved their range limitations. German tactical superiority had evaporated. The supply chain sustaining paper drop tank production exemplified remarkable Allied industrial collaboration. Bowater Lloyd, which had manufactured 60% of British newsprint before the conflict, converted portions of its facilities at Sittingbourne and Kemsley to tank manufacturing. The company's experience with paper lamination techniques and their secured access to raw materials positioned them perfectly for this enterprise. Recycled newspapers and discarded packaging materials supplied the kraft paper component, while the formaldehyde resin glue came from Imperial Chemical Industries factories, utilizing materials that didn't strain other war production priorities. From raw materials through finished product required approximately 72 hours. Manufacturing occurred through distributed arrangements across Britain, with workshop and home-based workers contributing their labor to the war effort. Heavy brown paper wrapping protected tanks during transport, and this packaging efficiency meant far greater quantities of paper tanks could be carried aboard cargo aircraft compared to heavier metal alternatives. Master Sergeant Donald Marner of the 357th Fighter Group maintained meticulous records of drop tank logistics at Liston Airfield, documentation that survived into the post-war period. His teams commenced operations at 2 in the morning on mission days. Unwrapping tanks, verifying seals remained intact, and positioning them on aircraft attachment points. The mounting mechanism incorporated elegant simplicity, with tanks connecting through standard bomb racks equipped with quick-release fixtures. A simple lever actuation from the cockpit simultaneously jettisoned both tanks, an essential capability during air combat maneuvering. The fuel delivery system integrated seamlessly with existing aircraft plumbing, employing check valves that prevented fuel loss once the tank separated from the airframe. The crucial constraint involved the formaldehyde glue gradually dissolving from contact with fuel, producing leaks after several hours, making these strictly consumable items that required filling immediately preceding takeoff. By May 1944, measurable evidence demonstrated the devastating impact of persistent long-range fighter escort. Before effective long-range escort became standard, the 8th Air Force absorbed catastrophic losses. October 1943 had recorded monthly attrition rates approaching 7.6%, with the notorious Black Thursday mission reaching 20.6% losses. Once P-51s carrying drop tanks established regular escort protection, overall campaign loss rates fell to between 1.5 and 2.2%. This dramatic reduction prevented the deaths of thousands of aircrews and rendered the strategic bombing campaign economically sustainable. Republic aviation engineers analyzing the technical aspects identified unexpected benefits from paper tank construction beyond weight reduction. The aerodynamic profile proved superior to metal tanks, producing less drag during flight. When enemy fire struck them, they would tear rather than detonate with explosive force. Additionally, the material composition permitted eventual biodegradation when abandoned in fields or forests, unlike permanent metal tanks that became lasting hazards to agricultural operations. Lieutenant Colonel John Meyer, who would complete the war having achieved 24 aerial victories, participated in the March 6 Berlin mission. His preserved combat report, catalogued in the National Archives, provides detailed pilot documentation of paper tank performance at altitude. He launched at 10:45 hours, carrying two 108-gallon paper tanks, experienced flawless fuel transfer during the entire flight, released the tanks at 13:47 hours near Wittenberg when Focke-Wulf fighters attacked, and engaged immediately following tank separation. The weight decrease after dropping the tanks produced dramatic performance improvements. He destroyed one FW-190, damaged another, and returned to base with 45 gallons remaining. Without those paper tanks, Meyer documented, they would have been forced to reverse course near Brunswick. The strategic implications extended beyond bomber protection calculations. Extended range capability allowed American fighters to penetrate deep German territory, conducting fighter sweeps, attacking airfields, rail infrastructure, and dispersed targets of opportunity. Colonel Hubertus Zemke, commanding the 56th Fighter Group, completed a tactical evaluation in May 1944, concluding that the extended range provided by British paper tanks had fundamentally restructured the air war, enabling American forces to seize complete initiative. German responses to the Allied range advantage appeared in captured documents recovered after the conflict's conclusion. A Messerschmitt technical intelligence report dated May 15, 1944, acknowledged that American forces were employing expendable fuel tanks of revolutionary design, incorporating laminated paper and phenolic resin impregnation. German attempts to duplicate this technology failed not from insufficient technical comprehension, but from fundamental structural deficiencies in their war economy. Paper production capacity remained severely constrained, with most German mills redirected to producing military maps and administrative documents. Resin materials were allocated to aircraft manufacturing. Most fundamentally, they possessed no equivalent to the distributed manufacturing network that provided Allied production such resilience. Luftwaffe leadership recognized the strategic implications immediately. Post-war interrogations of senior Luftwaffe officers revealed acknowledgement of long-range fighter impact, though the frequently cited Göring statement regarding seeing Mustangs over Berlin cannot be verified within primary source documentation. Testimony recorded in the Strategic Bombing Survey indicates he stated that long-range American fighters delivered substantial strategic damage to German planning and represented one of the paramount decisive influences on the ultimate outcome. When fighters appeared over Berlin, he acknowledged, the consequences would prove tragic for Germany. General Adolf Galland, the fighter general, similarly testified that American fighters roaming across all German territory with complete freedom had effectively dismantled the Luftwaffe's defensive scheme. By June 1944, paper drop tanks had achieved standard equipment status for fighter operations. Sergeant James Patterson, quartermaster at Duxford, preserved logistics records demonstrating that paper tanks demanded only 1/10 the cargo space required by metal tanks during transport from manufacturing facilities to operational airfields. A single C-47 transport aircraft could accommodate hundreds of flattened paper tanks compared to 40 metal tanks. This logistical efficiency proved crucial for sustaining forward airfields established in France following D-Day, maintaining operational capacity even when ground transportation networks faced severe constraints. the fields of France bore silent witness to the toll that warfare exacted on the land itself. After the fighting ended, farmers documented the wreckage scattered across their property. Metal tanks, twisted and rusted, lay embedded in the soil where they'd fallen. These iron hulks killed livestock, shattered plowshares, and demanded years of grueling cleanup work. The paper tanks, by contrast, simply dissolved when the winter rains came. All that remained were the metal fittings, stripped and sold for scrap, leaving barely a trace behind. Captain Donald Bryan flew with the 352nd Fighter Group when he encountered one of the rare mechanical failures that plagued the program. On July 18, 1944, at 25,000 feet somewhere over Hanover, his port tank sprang a leak. Fuel began hemorrhaging from the damaged container, bleeding away roughly half the supply before he managed to shut it off. Yet Bryan remained calm. He switched to his starboard tank and still had enough fuel to make it home with room to spare. The redundancy built into the system had saved him, proving the designers had thought through every contingency. Through 1944, improvements kept coming. The second-generation tanks featured better resin formulas that transformed how long fuel could be stored. What once lasted 5 hours now lasted 12, letting ground crews load everything the night before rather than rushing around in the final frantic minutes before takeoff. The new formulation also handled cold better, preventing fuel lines from freezing solid at the extreme altitudes where fighters operated. The invasion of Normandy on June 6, 1944, showed what these tanks had made possible. Fighter bombers carrying paper drop tanks could reach far inland, striking German reinforcements hundreds of miles from the beaches. Captain Robert Johnson of the 56th Fighter Group flew 3 separate missions that day, each one extending deep into France. With the tanks extending his reach, he could stay over the combat zone, circle and wait for enemy movement, then strike with precision. Providing uninterrupted fighter protection over the invasion beaches and throughout the French countryside proved absolutely critical to Operation Overlord's success. The production numbers from the middle of 1944 revealed the enormous scale of the effort. British factories churned out thousands of these tanks each month, with Bowater Lloyd leading the charge as the primary manufacturer, supported by other facilities working at maximum capacity. The entire Allied fighter force across Northern Europe received fresh tanks for every single mission. Metal tank production, limited by scarce aluminum and demanding resources that aircraft production desperately needed, simply couldn't keep pace. Colonel Francis Gabreski, the leading American ace in Europe with 28 confirmed kills, flew his most devastating mission on July 5, 1944, relying entirely on paper drop tanks. Leading the 61st Fighter Squadron toward Magdeburg, Gabreski spotted enemy fighters and dropped his tanks near Brandenburg. Once lighter and more agile, he shot down 3 Messerschmitt Bf-109s. His report afterward noted that the tanks had performed flawlessly at 30,000 feet, despite temperatures plummeting to 40 below zero. They'd released cleanly when he needed them gone, and the climb rate improvement was exactly what he needed. By September, the Luftwaffe Day fighter force was essentially finished. General Galland informed Hitler of a catastrophe. American fighters were ranging across all of Germany, unopposed, untouchable. Long-range escort had accomplished more than just protecting bombers. It had systematically hunted down and destroyed the Luftwaffe through relentless fighter sweeps. German pilot training programs, forced to operate from scattered airfields constantly under attack, were producing pilots with barely 50 hours of flight time. American pilots, by comparison, brought 400 hours of experience to the fight. First Lieutenant Urban Drew of the 361st Fighter Group pulled off something extraordinary on October 7, 1944. Flying with 2 108-gallon paper tanks, he escorted bombers all the way to Politz near the Polish border, a round trip of 1,400 miles. After dropping the tanks near the target, he encountered 2 Me-262 jets and shot them both down, becoming one of the first pilots to claim victories against Germany's revolutionary new fighters. Paper tank logistics became absolutely essential when the Battle of the Bulge erupted in December 1944. Forward airfields had been hastily scraped from frozen ground. Supply lines were stretched to breaking point. The lightweight paper tanks could be transported by light aircraft or even dropped by parachute. Captain Jack Ilfrey commanded the 20th Fighter Group during the surge operations, and he documented days when pilots flew 3 missions, each time launching with fresh tanks. Ground crews somehow managed to rearm, refuel and bolt on brand new tanks in just 20 minutes. A German technical intelligence officer, Major Wilhelm Hoffmann, was captured in April 1945. When American interrogators questioned him, Hoffmann revealed that German command tracked every innovation in Allied fighter capability with intense interest. The appearance of paper drop tanks, he stated, represented something more strategically significant than any new aircraft design. It meant nowhere in the Reich remained safe from fighter attack. Their entire air defense strategy, built around concentric rings of fighter bases, became instantly obsolete. The numbers told a devastating story. In 1943, before long-range escort became widespread, German fighter production had actually climbed despite relentless bombing. Yet by late 1944, with Mustangs prowling over every German factory, fighter production plummeted by 40%. Even worse, fuel production crashed by 90%, grounding the fighters that were built. Lieutenant Colonel John Landers commanded the 78th Fighter Group and flew 103 combat missions, many of them with paper drop tanks slung under his wings. Years later, speaking to Air Force historians in 1962, Landers called the paper drop tank the unsung hero of the air war. Simple, cheap, absolutely essential. Without those British paper tanks, he said, Berlin would have been unreachable. Without that capability, the Luftwaffe would never have been broken. The manufacturing techniques developed for paper drop tanks would echo through post-war industry in surprising ways. The lamination process found its way into civilian aircraft components and eventually into aerospace work. The quality control procedures established at Bowater Lloyd became the template for British manufacturing standards. Workers trained in precision paper construction went on to found companies making everything from airplane cabin panels to architectural materials. Major Richard Turner flew with the 356th Fighter Group and later wrote his perspective in a 1946 memoir. He called those paper tanks their passports to Berlin, looking absolutely ridiculous but performing flawlessly. Across 89 missions, he never experienced a single failure. Soviet observers attached to American units sent reports back to Moscow about the paper tank innovation. Colonel Ivan Kozadub, the Soviet Union's top-scoring ace, examined captured German drop tanks and compared them to American paper tanks in 1945. His assessment noted that American tanks surpassed German designs in every category, achieved through elegant simplicity rather than advanced technology. The final push toward Germany demanded production at staggering scale. Every fighter mission over Germany deployed fresh tanks. Ground crews at forward bases in Belgium and Holland could outfit entire fighter groups in mere hours rather than consuming days. Lieutenant Robert Powell flew with the 55th Fighter Group and experienced the ultimate proof of paper tank reliability on March 24, 1945, during Operation Varsity at the Rhine crossing. He took off at 600 carrying 2 108-gallon paper tanks, flew to the Rhine, and dropped them when Me-262s jumped him near Frankfurt. After a 15-minute engagement, he landed at a forward strip, took on fresh tanks, and flew another mission, demonstrating the system's flexibility and dependability. The final major employment came on April 25, 1945, when Mustangs escorted reconnaissance aircraft to Hitler's mountain retreat at Berchtesgaden, a round trip of 1,400 miles. The mission showcased total Allied air dominance, with fighters ranging over the remotest corners of the Reich without opposition. Colonel Benjamin Davis, Jr., commander of the 322nd Fighter Group, the famous Tuskegee Airman, used paper drop tanks on escort missions from Italy into southern Germany. His after-action report from March 31, 1945, stated that the 108-gallon tanks allowed his pilots to escort bombers to Munich and engage enemy fighters throughout the mission, with perfect performance at altitudes exceeding 30,000 feet. These simple paper tanks gave them the range to prove themselves as fighter pilots. German civilian morale suffered as letters and diaries captured after the war revealed. Citizens wrote about American fighters constantly overhead, dropping fuel tanks made of paper in parks and streets, demonstrating such obscene wealth that they could carry fuel in paper containers and simply throw them away. Pentagon analysis after the war documented the strategic importance of the paper drop tank program. The aluminum savings alone justified every penny spent. Reduced shipping costs simplified the entire logistics chain, and decreased ground crew requirements multiplied the benefits. Most crucially, the extended fighter range saved an estimated 8,000 bomber crew lives by bringing loss rates from catastrophic 1943 levels down to manageable numbers by early 1944. Air Chief Marshal Arthur Harris commanded RAF Bomber Command and initially doubted daylight bombing tactics. Yet in his memoirs, he acknowledged that American success in extending fighter range through disposable tanks vindicated their entire strategic approach. General James Doolittle commanded the 8th Air Force, and in his final report offered this assessment. The extension of fighter range through auxiliary fuel tanks, particularly the British-manufactured paper variety, represented the single most important tactical development of the entire air war in Europe. It transformed the P-51 from a competent fighter into a war-winning weapon system. The ability to escort bombers to any target in Germany broke the Luftwaffe's back and established the Allied air supremacy absolutely essential for victory. The human element extended to thousands of workers manufacturing the tanks. At the Sittingbourne facility, production workers, 70% of them women, worked 3 shifts relentlessly to meet demand. They understood that every tank they constructed meant Allied air crews could fly farther and return home alive. The technical specifications achieved were remarkable for such apparently simple devices. Each 108-gallon tank withstood 3 Gs of acceleration when full, 9 Gs when empty. They functioned flawlessly across extreme temperature ranges and altitudes. The fuel transfer rate matched internal tank systems, creating seamless transition during combat. All accomplished using compressed paper and plastic resin, materials available in any industrialized nation, yet combined through uniquely Anglo-American innovation and production capability. Willy Messerschmitt, the German aircraft designer, was interrogated after the war. He admitted that they knew about auxiliary tanks and used them, but never imagined that anyone would mass-produce disposable tanks from non-strategic materials. The Americans and British had transformed a logistics problem into a production advantage. The influence on military doctrine was profound and enduring. The United States Air Force incorporated long-range fighter escort as a fundamental principle, influencing aircraft design throughout the Cold War and beyond. The concept of disposable components to extend capability became standard practice, from fuel tanks to gear supports to weapons pylons. The paper tank proved that innovation didn't demand exotic materials or revolutionary technology, merely creative application of existing resources. Lieutenant General William Kepner commanded the 8th Fighter Command and testified before Congress in 1946. "The paper drop tank gave us air superiority over Europe," he stated. "Without it, our bombers would have continued suffering unacceptable losses. Without it, our fighters couldn't have pursued the Luftwaffe to extinction. Without it, D-Day might have failed." The environmental legacy was significant, though largely forgotten at the time. Roughly 15,000 paper tanks were dropped over Europe during the war and biodegraded within months, unlike metal tanks that became permanent environmental hazards. French agricultural reports from 1946 showed no lasting soil contamination from paper tanks, while regions littered with metal tanks required extensive cleanup continuing into the 1950s. The quality control innovations developed for paper tank production influenced manufacturing standards worldwide. The requirement for complete reliability in a disposable product drove development of statistical process control later adopted across industries. The concept that simple, adequate solutions could outperform over-engineered alternatives reduced costs while maintaining reliability. The strategic implications extended far beyond World War II. During the Berlin airlift of 1948, transport aircraft used disposable tanks based on wartime paper tank technology to extend their range. The Korean War saw improved versions employed by F-51 Mustangs flying from Japan. The technology evolved into modern composite materials, but the fundamental concept of lightweight disposable range extension remained unchanged. The last combat use of paper drop tanks in World War II came on May 7, 1945, one day before VE Day, when Mustangs of the 357th Fighter Group flew a final patrol over Czechoslovakia. Lieutenant Robert Foy flew his 89th mission that day, carrying two 108-gallon paper tanks to Prague and back, dropping them over a farmer's field near Pilsen. Through decades of veterans' reunions, crew chiefs and pilots shared stories about paper tanks. At the 1995 50th anniversary gathering at Duxford, former Luftwaffe General Adolf Galland met with American fighter pilots. When asked about the turning point of the air war, Galland pointed to a displayed paper tank. That simple thing, he said, meant they could never be safe, never rest, never rebuild. It brought the air war to their doorsteps every single day until they had nothing left to fly. The technological simplicity concealed sophisticated understanding of materials, science, aerodynamics, and production engineering. Each tank embodied thousands of decisions about construction, materials, testing, and quality control. Success came from making all these decisions correctly, then executing at unprecedented scale. Captain Louis Kurds flew Mustangs with the 3rd Air Commando Group in both European and Pacific theaters. He compared the impact across different combat zones, noting that the same simple solution worked in Pacific humidity as well as European cold, demonstrating engineering that transcended specific theater requirements. The legacy lived on in unexpected ways. The phenolic resin technology, developed for tank construction, became the basis for early circuit boards in the electronics revolution. The lamination presses designed for tank production were repurposed for manufacturing television cabinets in the 1950s. Workers trained in precision paper construction founded companies producing everything from airplane interior panels to architectural components. Wing Commander Peter Brothers of the RAF observed American operations with paper drop tanks and reported that the Americans approached war like a business problem, buying range by the gallon in disposable containers with no romance or elegance, just brutal efficiency. The British provided the technology, the Americans provided mass production, and together they gave the bombers safe passage to Berlin. The United States Strategic Bombing Survey's final accounting documented that auxiliary fuel tanks, particularly the 108-gallon laminated paper tanks, extended fighter escort range from 475 miles to 850 miles. This 79% increase in range brought every German target within escort capability. The resulting reduction in bomber losses saved approximately 8,000 aircrew lives and enabled the strategic bombing campaign to achieve its objectives. The paper drop tank story reveals a fundamental truth about modern warfare. Victory often depends not on revolutionary technology, but on innovative application of simple solutions at massive scale. A British paper company, American fighter planes, and compressed paper soaked in plastic resin combined to break the Luftwaffe and secure Allied air supremacy. The total wartime production of approximately 15,000 paper drop tanks, dismissed as impractical by experts, proved decisive in achieving air superiority over Germany. Each tank that functioned perfectly represented a life saved, a mission completed, a step closer to victory. The bombers could finally reach their targets with protection. The fighters could finally fight where the enemy lived, and the war in the air was won not by superior aircraft alone, but by superior range, provided by disposable paper tanks that looked like nothing more than oversized cardboard tubes, yet carried within them the fuel for victory. The innovation arose from necessity when metal was scarce and bombers were dying. British ingenuity met American industrial capacity, creating a solution so simple it seemed impossible. Paper and resin, newspaper companies and fighter planes, converging to solve one of the war's most critical challenges. When Lieutenant William Overstreet flew over Berlin on March 4, 1944, with paper tanks beneath his wings, he carried the culmination of months of development, testing, and production by thousands of workers who would never see combat, but whose contribution proved as vital as any military victory. The paper drop tank story stands as testament to the power of practical innovation over complex engineering, proving that sometimes the best solution is not the most advanced, but the most achievable at scale when it matters most.